to compare boiling point order. So the next topic is to comparison of boiling point order. Now, in different examinations, there you can expect one question which telling you to compare boiling point. In those questions, there will be a common pattern. What is the pattern? There will be comparison of non-polar molecules versus polar molecules. So in this case, non-polar will have less boiling point than polar molecule. So in comparison, if you see any polar molecule, obviously that will have much more boiling point because of electronic interaction between them. Now, if they compare you, they give question with the comparison of non-polar molecules only. Then first you have to check molecular weight. Molecular weight proportional to boiling point. More the molecular weight, more will be boiling point. The second one, if this criteria is same, if this is same, then you have to jump to the second option, that is branching. More the branching, if branching is high, then van der Waal interaction is low, then boiling point will be lower. So branching proportional to 1 by boiling point. So I will be taking the examples, but before that, if they only make you comparison of polar molecules, then what you have to do? First, you have to check hydrogen bonding. Hydrogen bonding. Second, you have to check polarity. That means difference in electronegativity. Third one, you have to check electrostatic interaction. Electrostatic interaction. And this depends on the amount of charge and amount of distance. This Q1, Q2 by R square, the formula of Coulomb, we know electrostatic interaction. Fourth one is a dipole moment. Dipole moment. So we have to check all these factors and try to check these factors in this sequence. So this is the whole uh, picture of boiling point comparison. Now let's take some examples. First one, example is butane, pentane, and hexane. Now all these are non-polar molecules. So they have given the comparison of among non-polar molecules. So first we have to check molecular weight. We know there are 1, 2, 3, 4 carbon, 5 carbon, 6 carbon. So obviously molecular weight here will be higher. So definitely from this direction to this direction, molecular weight is increasing, and molecular is increasing means actually van der Waal interaction is increasing, and that's why boiling point increasing. Second example, let's say pentane, isopentane, neopentane. Now here, these all again non-polar, but molecular weight also same. Then we have to go to the second point. This is branching. Here, the first one there is no branching. Second one there is one branching. Third one there is two branching. How here is two branching? Suppose you have to consider it as a main chain. That means this will act as branch. Again, here you have to consider this, for example, this as a main chain, then there will be two branch. So from left to right, branching increases. What happens with increasing of branching? When there is no branching, that means the molecule is kind of linear, then it is a rod-like structure. And when it is associated with more branching, then it is spherical type of structure. Now, when two rod, if we put two rods side by side, then their area of contact will be higher. But if we put two spheres side by side, then the area of contact is very low. More the area of contact, more will be van der Waal attraction. Then these two systems separation will be difficult. So there will be more energy, more heat required to separate them, as van der Waal interaction is more, as area is higher, as shape is cylindrical. So more heat required means boiling point will be more. More heat is required to separate them, to take them far apart. Taking them far apart means actually boiling point means solid. Uh, sorry, For example, liquid to gas. Okay, so actually molecules are far apart in less far apart in liquid. In gas, they're very much far apart. So boiling point is actually taking two molecules far away. Okay, so that's why when the area of contact is high, when the shape is cylindrical, that means less branching, then area of contact will be higher. Then more heat will be required to separate them as van der Rohe interaction is higher. So that's why this will have highest boiling point. So from left to right, boiling point will drop or boiling point will decrease. Now let's go to third example. Third example. For example, OH, NH2, and this carbon CH3. Now among these three, now uh, there is a comparison of non-polar versus polar. These two are polar, but this is a non-polar. Then obviously the non-polar will be least. Okay, least boiling point. Now among these two polar molecule, so if we look upon polarity or hydrogen bonding, okay, more the hydrogen bond. Suppose hydrogen bond is more, then two molecule are connected very strongly. Then more heat will be required to separate them. Then boiling point will be higher. Now OH or NH2. For OH, hydrogen is very much delta positive. Delta positive is high because oxygen is very much delta negative. So it will generate hydrogen bond in a stronger manner. So hydrogen bond is stronger for this OH and weaker for NH2. So more hydrogen bond is for OH, less hydrogen bond is for or less strong hydrogen bond for NH2. Then from right to left, our boiling point will increase. First one is least because it is non-polar. And among these two, extent of hydrogen bond. Here hydrogen bond more, here hydrogen bond less or less strong. Now let's go to another type of question. For example, 4. Okay. For example, 4. Now the question is O NH this. This is also kind of same, but here no hydrogen bond. It is non-polar, so it will have least boiling point. For the first two, then hydrogen bond, there is no hydrogen bond. These two are polar, so I am checking the parameters of polar. So let's go to polarity. Now which one is has more polarity? Obviously oxygen will generate more delta negative and delta positive over this carbon. So this is more polar. So again from right to left, boiling point will increase. Okay. uh, fifth one, for example, cis 2 butene, chlorine, chlorine, uh, cis 2 dichloro actually, chlorine, chlorine. Now these two are actually polar versus non-polar, right? So this one is non-polar, second one is non-polar, first one is polar. So first one will have more dipole moment and thereby more boiling point. So these are all kind of question associated with the boiling point. So first you have to check the comparison, the elements given are polar or non-polar. If everything is polar, then first go to molecular weight. Second, if molecular weight is same, then go for branching. If the comparison is in polar, then follow these things accordingly. More hydrogen bond means more boiling point, more polarity means more boiling point, more dipole moment means more boiling point, and more electrostatic interaction means more boiling point. And electrostatic interaction depends on both the thing charge and distance. More the charge means more electrostatic interaction, more the distance means less electrostatic interaction. And if they give example with these two mix, then first categorize them polar and non-polar. So for example, this type of questions. So non-polar, if they give four examples of two polar and two non-polar, so first categorize them. So less polar will be least have least boiling point, and more polar will have more boiling point. Then compare this accordingly. So hope you have understood it, and this kind of question are very easy, and you will be able to solve it. In the next session, next discussion, we will be covering resonance energy.